Hey, so we're going to take a look at some more advanced simplification problems using the rules of exponents. And well, here we go. I'm going to turn off the webcam because half the time my back is going to be facing you anyway, so I don't think that's probably too exciting. But I'll turn it back on every once in a while, all right? Just to check on you. All right. Maybe I don't know how to turn it off. Oh, there we go. Okay, so here we go. The first thing we're going to be looking at is simplifying 2 times a to the third times b to the fourth, and this whole thing is squared, and then we're going to multiply this times a, and this is all over 12a to the ninth b. All right, so we know that when we have an exponent being applied to bases that already have exponents, we're going to multiply the exponents. And so we have just regular 2 squared, so that's just going to be 4. A to the third squared is going to be a to the sixth. B to the fourth squared is going to be b to the eighth. And then we're still multiplying this by an a, and this is all over 12a to the ninth b. Well, the first thing I noticed is in the numerator, I have a to the sixth and a. So what I'm going to do is I want to multiply those together. And when you multiply variables with this that are the same base, you add the exponents. So in this case, 6 times, or 6 plus 1 is just going to be 7. So that gives me a to the seventh in the numerator. All right, so now we can reduce, which is really the name of the game. We want to reduce things as quickly and as much as possible. It just makes life easier for us. So I can't help but notice we have 4 and 12. Well, 4 goes into both of them. 4 goes into 4 once. 4 goes into 12 3 times. And we have 7 a's multiplied together in the numerator. We have 9 a's in the denominator. Well, there are 2 more a's in the denominator than there are in the numerator, so that means we're going to end up with a to the second in the denominator. And then we have b to the eighth divided by b, that's 8 minus 1, that's 7. So we have 7 b's left in the numerator, 7 b's multiplied together, that is. And so let's put these things together. So we have 1 times b to the seventh, well that's just b to the seventh. We have 3 times a to the second, so that's 3a to the second. And that's all we got. That is the end of the road there. All right, so let's take a look at b. Now b is going to be a little bit longer than that one. I just want to review some quick rules of exponents. And we have 2 that we used in question A. We said a to the x to the y power is equal to a to the x times y power. We had a to the x times a to the y is equal to a. This is when we add the values together. Well, we also had division, right? So if we had a to the x over a to the y, that's going to be equal to the a to the x minus y power. And then the new one that we're going to throw in there is a to the negative x power is equal to 1 over a to the power of positive x. Now this works both ways. If I had 1 over a to the negative x, I could then rewrite this as a to the positive x over 1. So those are the rules that I'm going to be working on in problem B. All right, and I gotta tell you, I'm a little nervous. X minus 1 as an exponent? Oh, come on. All right. Well, hopefully we can reduce our way out of this. So here we go. All right, so first we're going to apply this exponent right here. We're also going to apply these. So that's going to give me 3a to the x minus 1 multiplied by a to the 2x power. And that's all going to be over a to the 3x times 9, because 3 squared is 9, a squared. All right, and so let's see from there. Well, I can't really combine the terms that in my numerator or the denominator because their exponents are different. So is there anything I can do to reduce things? Because we like to reduce, right? Well, I noticed that we have a to the 3x and we have an a to the 2x. Well, that's reducible because their exponents are of the same variety. They're something times x. Well, if I have 2x's here and 3x's here, well, I could just subtract them, right? And so that's going to cancel out this term completely, and we're going to end up with a to the x power over here. Because remember, we're subtracting the exponents here. Well, 3 goes into 9 3 times, and I still have my a squared. And so when I put this back together, I end up with a to the x minus 1 over a to the x times 3a squared. All right, so now we need a little luck here, or we need to do something, because we have x minus 1, we have x over here. Man, boy, would I like to be able to combine those together. Oh, wait a second. I can just use this rule again, can't I? All right, so that means I'd be subtracting the exponents, right? So that would mean I'd have, use a different color because colors are fun. I like this color green. Oh, purple. All right, so I can subtract the exponents, which would give me a to the x minus 1 minus x, because, I'm subtracting the exponents. And that would be over 3a squared. Well, what is x minus x? 0. Oh, okay. So that gives me a to the negative first over 3a squared. Now, we know we cannot leave an answer with a negative exponent. So that's when this rule here is going to come into play. So a to the negative first is equal to 1 over a to the first. So that's just going to give me 1 over 3a squared times a. Well, what's a squared times a? A to the third. So if our final answer is 1 over 3a to the third. Well, all right, so we're going to take a look at C and D in a separate video.